Hey, sunshines. We're going to start parallel lines and transversals. We're going to talk about the angle pairs that they form, but first we're going to talk about what the heck they are. So, parallel lines are two lines that continue in the same direction and never touch. So, these two blue lines are parallel. If they continued, they obviously don't touch within the picture, but they're going in the same direction. So, if they continued forever and ever, they would never ever touch each other. And we put little arrows on like this to indicate that they're parallel. So just like you have a little slash for congruence, you use little arrows. So two little arrows means that these two lines are parallel to each other because they have the same number of arrows. If I had more than one set of parallel lines in the picture, then I would add, then I would add uh, different numbers of arrows for each set. So I'd have two arrows for this set, and I'd have maybe one arrow for a different set. A transversal is a line or a segment array that passes through two or more other lines or segments or rays. So this red segment here is a transversal because it's passing through the two blue segments. Now, I said segments and rays in this definition and not in this one because it's important to remember that segments are only parallel if you continued the lines and the lines would remain parallel. Just because two segments aren't touching each other where they're pictured doesn't mean that they're parallel. You have to be able to extend them and know that they will never, ever, ever touch each other. On a Cartesian plane, that means they have the same slope because they're going in the same direction. They're at the same angle with respect to, so these are both these are both going slightly downward, like maybe 10 degrees downward. So they're going in the same direction. So they'll never get closer to one another. They'll never ever touch. The interior is a space between two lines or segments or rays. Uh, but again, you usually look at it as if you extended them out. So this is the interior here, which turns blue when I hover over it. And then the exterior is the space on the outside. Usually we're focused on parallel lines when we talk about this, but sometimes you'll do this with lines that you don't know if they're parallel. So the interior and exterior can still exist, but you're still going to be talking about lines that aren't intersecting visually, usually. You can still have an interior of an angle and an exterior of an angle, but for the purposes of this chapter, we're focused on lines that are parallel or lines that we think might be parallel. When we want to talk about the angle pairs that they form. So if you have a pair of lines and a transversal, you get all these angle pairs. Now, the lines don't have to be parallel to have the names of these angle pairs, which is why I didn't put the parallel markers on the pictures. So for this picture, my two angles are both between the lines. That means they're both in the interior. They're also on opposite sides of the transversal. This is called alternate. So this pair of angles is alternate interior. They're on alternate sides of the transversal and they're in the interior of the pair of lines. This one over here is still alternate, but this time they're outside of the pair of lines. So these are called alternate exterior. They're on alternate sides of the transversal and they're outside in the exterior of the pair of lines. And for this one over here, they're in between again. They're in that interior, but now they're on the same side of the transversal. So these are called same side interior. Sometimes you'll see them called consecutive interior. I don't really like that terminology as much, so I prefer same side. You'll see both if you go looking for angle pair things, but just be aware sometimes you'll see something called consecutive interior. Those are the same thing as same side interior. Now for this one, we're in the exterior. But again, we're still on the same side of our transversal. So both angles are in that exterior. To be called exterior angles, they have to both be in that exterior on opposite sides of the pair of lines. So for these four angles, you have a pretty systematic naming scheme. You check whether they're alternate or same side. You check whether they're interior or exterior. But then you have some other oddball cases where over here, I've got one on the inside and one on the outside. They're on the same side of the transversal, but they're not both in the interior or both in the exterior. So they actually have a totally different name. These are called corresponding angles because they're in the exact same position with respect to each other. They're both along that same transversal. So they're on the same side of the transversal, but if you go from one line to another, they're both below the line, or they're both above the line, or they're both to the left or they're both to the right. If I took this whole intersection and just slid it down here, they'd line up. Now, if the lines are parallel, and that's a big if, these angle pairs are always going to be congruent to each other. So as I move this transversal, if I move this transversal over, if I move this line and tilt it, then this angle here is going to get bigger. This angle here is going to get bigger if these two lines stay in the same position. So these two angles that are on alternate sides like this will continue to stay the same size. Same goes for these guys. If I tilt that transversal, these two angles will get bigger or smaller. Corresponding angles, same thing. If I tilt that transversal, they'll both get bigger or smaller. This is the opposite effect. If I tilt the transversal, this one's going to get bigger and this one's going to get smaller. So they maintain the same sum, they stay supplementary. So we also have a couple older angle pairs that we don't need parallel lines for, that we don't need a pair of lines for. Vertical angles exist on a single intersection. So we're completely ignoring this second line from the pair. So, but remember that vertical angles exist because they're going to come back all the time this chapter. Vertical angles are always congruent. It doesn't matter whether the lines are parallel or not because you're not using the second line. Linear pairs are always supplementary. Again, it doesn't matter whether whether the lines are parallel because you're not using the second line. Linear pairs are when they're next to each other in the same intersection. Vertical angles are when they're across from each other in the same intersection. So it's really important to be careful and make sure when you're looking at your same side exterior that you don't mix up same side exterior and linear pairs. They are both supplementary, but there are times when it matters that you have the correct terminology. A linear pair could be the two angles that are both above the pair of parallel lines. Same side exterior requires that they're using both intersections. They're both on the exterior, but they're using both intersections. But if you're looking at a situation where you know your lines are parallel, then you can eyeball it as long as they look parallel and you know that they're supposed to be parallel. You can say, okay, the lines that look obtuse, if they all look obtuse, then they're congruent to each other. The lines that look acute, the angles that look acute, if they're both acute, then they're congruent to each other. If one looks acute and one looks obtuse, then they're going to be supplementary. You can only eyeball it like that if you know that the lines that look parallel are actually supposed to be parallel. In general, you can't take a drawing for granted. Just because the lines look parallel doesn't mean that they are. I could have a line that's at, I could have, this line could be at a 10-degree slope and this line could be at a 12-degree slope. Then the angles are going to be slightly different. They're going to be close to that supplementary, but they're not quite going to be supplementary because the lines don't quite match up. So these are your angle pairs of parallel lines. Now, if I want to find the measure of angle 2, I know that angle 1 is 100 degrees. So these are, I can eyeball it. If I know that the lines are parallel, because now they're given as being parallel, then I can say, okay, all of the obtuse angles are congruent to each other. So this, and this. So this is going to be 100 degrees. That said, it's still a good idea to pay attention to your angle pairs and to practice naming them. So these are on alternate sides of the transversal and they're both in the exterior. So these are alternate exteriors. So I know that they're going to be congruent. Since they're congruent, I get to just do the easy thing and copy the number over. Because alternate exterior angles of parallel lines are congruent. Now this one over here is just slightly trickier. These are not congruent. These are same side interior angles, so they're supplementary. So that means I'm going to set this one equal to x. So I can say that x plus 100 equals 180. Supplementary means they add up to 180 degrees. So angle 1 is going to be 80 degrees. When we do the slightly trickier version where you have algebraic expressions instead of a number and a blank, you're still going to do the same thing. Congruent means they have the same measure, you set them equal to each other. And then you solve your equation. Remember, always be careful with your signs. If you subtract a number that's larger, you're going to get a negative coefficient. And if you divide by a negative, you're flipping your sign. So negative 20 divided by negative 2 turns into positive 10. So x equals 10. And then if you're finding angle measures, you're going to plug that back in. So you substitute this value for the x in each expression and you simplify. And so I got 100 degrees for both. I knew that they're supposed to be congruent, so I could substitute it into one of them and then do like I did up here and just say, okay, I know the other one's 100 as well. But it's always a good idea to double check and make sure you didn't make some silly calculation error by plugging it into both of them as just kind of a sanity check. These guys over here are supplementary, so that means I'm going to add them together and set it equal to 180 degrees. When they're supplementary, you put them on the same side and you're adding them together. So I have angle 1 plus angle 2 equals 180. And then I just solve my equation. So y equals 5. And then you're going to plug your y value back into each expression to find the actual angle measures. So this one's 80 and this one's 100. Again, you could do the same thing as you did up here and just say, well, I solved for one of them. The other one is 180 minus that number. But again, it's a good idea to sanity check. Okay, 100 plus 80 equals 180. I'm good. I plugged them both in. I didn't just slip up somewhere over here. So now you have parallel lines and transversals and the angle pairs that they form.